Your Honor, now I'd like to call a team of physicists from Carnegie Vanguard High School to the stand. Good afternoon, Your Honor. So, Mrs. Tarasia, could you please explain to us how you guys were able to reach your verdict?
Yes. So for this, we need to describe some terms first. So forces and motions are based on Newton's laws of motions and describe the motion of a body in response to forces acting upon it. Forces and motions are involved in every part of a car crash. For example, Newton's first law of motion, inertia, plays a major role in our safety during a collision. In a car, our body is moving with the car as one body. So during a collision, the vehicle abruptly decelerates, and if one is not wearing their seatbelt, the unbalanced forces can throw one out of the car.
Another physics concept that uses inertia is momentum, which is described as a tendency for a body to remain its inertial motion, meaning that it keeps on moving. So this is represented by the equation momentum equals mass times velocity, and since velocity is a vector quantity being multiplied by a scalar quantity, momentum is a vector quantity. So conservation of momentum essentially states that momentum is always conserved, and this plays a vital role in understanding collisions. So for example, the momentum of the car and the truck before and after a collision should be equal because momentum is always conserved. So this can give us the initial velocity of the vehicles.
Lastly, kinematics describes the motion of points, bodies, and systems of bodies without considering the forces that causes them to move. This can help us find the various aspects such as time, velocity, acceleration, or displacement of an object. For example, we can use kinematics to determine the initial velocity of a vehicle post-collision.
So now we can move on to how our calculations led to our verdict. So firstly, we can focus on forces in motion to determine the coefficient of friction for the vehicles and the acceleration right after the collision. So to find the coefficient of friction, we can divide normal force by the force needed to drag the vehicles across a distance. So both of these were found by the police, and this gives us a coefficient of friction of 0.769 between the car tires and the road. The manufacturer of the truck has also said that the coefficient of friction of a truck is 70% of a car's due to technical reasons, so this gives us a mu of 0.538 between the truck tires and the road. And then we can multiply this coefficient of friction to their respective normal forces to find the force of friction, which is 10,458.4 newtons for the car and 37,498.6 newtons for the truck. And since friction is the only force acting on either of the vehicles after the collision, the force of friction is the net force. So we can then use the equation described by Newton's second law of force equals mass times acceleration to find the acceleration of the vehicles post-collision. So the force of friction that we calculated earlier can be plugged in for net force and then divided by the mass of the respective vehicles, which results in the acceleration. So this gives us an acceleration of negative 7.54 meters per second squared for the car and negative 5.28 meters per second squared for the truck post-collision.
Now we're able to use this acceleration to find the initial velocity of both of the vehicles post-collision. We can use the kinematics equation, final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. And since we know the final velocity of the vehicles is 0 because they both come to a stop at one point, we just find the acceleration, and the police were able to find the displacement of these vehicles. Plugging the respective values into the equation gives us the initial velocity of 11.12 meters per second for the car and 10.78 meters per second for the truck.
This can then be used to find the momentum by multiplying the mass by the velocity we just found. This gives us a momentum of 15,431.89 kilograms times meter second for the car and 76,598.82 kilograms times meter second for the truck. However, the collision occurs in a 2D plane, which means there's both a horizontal and vertical momentum. So we need both the horizontal and the vertical momentum of both of the vehicles post-collision. The vertical momentum of the vehicles can be found by using the sine function, and the horizontal can be found using the cosine function. This results in a horizontal momentum of 15,431.89 times cosine of 33, and vertical momentum of 15,431.89 times sine of 33 for the car, and 76,598.82 times cosine of 7 for the horizontal moment, and 76,598.82 times sine of 7 for the vertical momentum of the truck. The momentum is conserved throughout the whole process, meaning the total momentum pre-collision is the same as the momentum post-collision. However, the car moves in the vertical direction while the truck moves in the horizontal direction. Consequently, we only consider the total vertical momentum for the car and the total horizontal momentum for the truck. The total horizontal momentum is 88,970.14 kilograms times meters per second, and total vertical momentum is 17,739.86 kilograms times meters over second. Now we can use the momentum formula again to calculate the velocity, which would be momentum divided by mass of the vehicles pre-collision. This gives us a velocity of 12.78 meters per second for the car and 12.51 meters per second for the truck before collision.
This shows us that Mr. Garcia and Mrs. Wakefield were lying. Mrs. Wakefield claimed to be traveling at 6.7 meters per second, which is known to not be true because we found her velocity to be 12.51 meters per second. As for Mr. Garcia, he claimed to have stopped before entering the intersection. Given that he has accelerated at 3 meters per second square, as indicated by the Ford Motor Corporation, and the distance from the collision point to the traffic light is 13 meters, he should have been traveling at 8.83 meters per second for his claim to have been true. But we know that he was actually traveling at 12.78 meters per second while both drivers were lying. The truck had a flashing yellow light, which the car flashing red light, which means that the person in guilty is Mr. Garcia. Mr. Garcia had a red light, meaning that he had a full stop, but he didn't, and Mrs. Wakefield had the flashing yellow light, meaning that it was in her right of way.
Thank you for the verdict, and that is more than substantial evidence to prove that my client is not in fact guilty.